Hi everybody. We are going to look at rotations today. So if you remember when we talked about the different types of transformations, a rotation is really just taking a shape and turning it. So the shape will be congruent to its preimage because the size is not changing. And so it's the same size and the same shape, it's just that it has been turned. So we call that a rotation. We're going to look at all rotations, multiples of 90. So 90 degrees clockwise, counterclockwise, 180 degrees, 270 degrees, and so on. One thing that I want you to remember is that if the rotation does not specify the direction, so if it doesn't tell you to go counterclockwise or clockwise, you assume that you go counterclockwise. I'm actually going to make a note of that right away. So when not specified, shall say when the direction is not specified, we assume we rotate counterclockwise. Okay, so if you stop and think for a minute, when you look at a clock, clockwise means that the minute hand, the second hand, everything is kind of moving to the right, versus counterclockwise we can think of as a left turn. Whenever you're doing a rotation of 180 degrees, it doesn't matter whether you go clockwise or counterclockwise, because no matter what, you're going to end up in the same position. Because it's two turns, you can think of it as two turns. So in number one, what we want to do here is a rotation of 180 degrees. Now it says about the origin because that's going to be how we turn. So you don't have to worry too much about that. We're never going to do anything that's not about the origin. And so what I want you to do for these is I actually want you to take your paper and turn it 180 degrees. So to do that, we're going to treat it like every turn is 90 degrees. And this one, like I said, it doesn't matter which way you turn it. Because two turns either direction is going to end up being the exact same thing. So let's just say we're going to go counterclockwise. So we're going to take it and we're going to turn our paper two turns to the left. And what will happen is you're basically going to have your paper be upside down. So everybody take your paper upside down. I know you can't see the difference. Same thing. And what we're going to do is we're going to write out our points as we see them now. So for example, if I look at point Q, and your paper will be upside down just like mine is right now, I'm going to write down the new coordinates of point Q as I see them. So when I'm looking at it, this looks like the point 0, 1. If I look at point J, 1, 2, 3, 4, 5, 1, 2, 3. J is now 5, 3. And then I need to do H, which is 3, 5. So after you've written down those points with your paper upside down, you're going to turn your paper back, so right side up, and you are going to replot those points as you wrote them down. So yes, you're going to have to read upside down, read your writing upside down, but that's okay. So Q prime, we said was going to be 0, 1, which ends up being right here. J prime is 5, 3, which ends up being right here. And H prime is 3, 5, which is right here. Connect your points, create your triangle, and you should see that it looks like it has been rotated. The shape is congruent, and there you go. Now I have found that doing this is a lot easier than memorizing the rule, but I will tell you the rule just in case you ever need it. So the rule for rotating 180 degrees is to take your point, you might already be able to tell from your points you wrote down, and basically each coordinate changes to the opposite sign. So before, all of our coordinates were negative, now they're all positive. Okay, so let's look at number 2. We are now rotating 90 degrees counterclockwise about the origin. So 90 degrees counterclockwise means to take your paper and turn it one time to the left. So I'm going to take your paper to the left. And so when you start writing down your points, you're going to have, well, you'll see where I'm writing them, and that should help. So let's start with I. I prime should now be 0, 1, 2, 3, 4, 5. And if you have your paper facing the right way, it should look like my writing to you is the right side up. So if you've turned it the wrong way, it's not going to look right. S prime is negative 2, 2. And then we have B prime, negative 5, 4. So again, once you've written down those coordinates as you're seeing them with your paper turned, you can turn your paper back and you're going to replot your triangle with the points you wrote down. So 0, 5 is going to be up here. And that was I prime. Negative 2, 2 is S prime. And then negative 5, 4 is B prime. Okay, so you can see the triangle is congruent to the pre-image. It's just turned 90 degrees. Okay, let's go down to number 3. So here we are rotating 90 degrees clockwise. So clockwise means you're turning your paper once to the right. I'm going to write down my new points. Again, if my points don't look right to you, it's because your paper wasn't turned the right way. So we're going to have our new M be negative 2, 4. I'll do H next. Again, it doesn't really matter the order in which you're writing these points down. Negative 2, 1. Looks like F prime will be 3, 1. And B prime will be 1, 5. Okay, so when you're ready, we're going to replot. Negative 2, 1, 2, 3, 4. This is my M prime. H prime. It's F prime. And B prime is up here. Okay, so it should look like it's 90 degrees to the right. And you can kind of look at it and say, oh yeah, if I turned that once to the right, that looks like it's correct. Okay, so number 4, we're back to 180 degree rotation. Again, it doesn't say the direction because it doesn't matter. You can go 2 turns to the right or 2 turns to the left, and we're all going to end up in the same way. That's your okay, so for U prime, 4, 5. H prime, getting 2, 3. And for F prime, getting 1, 5. Okay, again, tie it up. You can really read the points upside down. So 4, 5. 2, 3. And 1, 5. And there you go. There is your 180 degree turn of that triangle. Okay, so if you look at 5 and 6, and these ones we're still going to do 90 degrees and 180, but now I'm asking you to actually plot the polygon yourself to start. So take a second. I will be quiet while you do that. Don't forget to label your points as you go. Okay, so there's your original quadrilateral. Okay, so we're going 90 degrees clockwise. So we are turning our paper one turn to the right. We're going to write down our new coordinates. I'm going to do this without talking so that we can compare when you're done writing these down, if you can get it. Okay, if you're ready, you can compare with what I wrote down. And then I'm going to turn and I'm going to plot those points. So this one we're going to have some overlap going in. So just make sure you're labeling your points. Okay, it should look like that. All right, let's keep going. So for number 6, we have 180 degrees about the origin. So I'm going to go ahead and plot my pre-image here. We have a triangle. Okay, so we need to go 180 degrees. So paper's completely upside down. And we can write down our new coordinates. Okay, let's go ahead and put paper back. And we're going to plot those. Okay, so that's how your 180 degree rotation should look. Now I just realized I didn't write up above. I wanted to show you the rule for that 90 degree rotation. So I'm going to put right here, rule for 90 degrees. And this was going to not only reverse your coordinates, but it was going to also change the sign of the y coordinate. Now again, I don't love the rules because it's hard to remember. There's a different rule for every direction and degree. But you're always welcome to write them out if that's something that you'd like to remember. For me, I just like to actually turn my paper and figure it out that way. Okay, so let's go on to the last part of this. Okay, so we are going to now figure out the coordinates of each new figure given the pre-image coordinates. So if you look at number 7, we're given 4 points here, and we're being told that we're going to rotate this polygon, this quadrilateral, 180 degrees. And so this might be a time that you choose to use your rule. And so if you remember, for the rotation of 180 degrees, it basically just changes the signs. And so if I needed to rewrite z, you would just say 1, 5. K prime, change the signs to all the opposites. Remember, 0 doesn't change, it's just 1, 0. C prime becomes -1, -1. And M prime would become -3, +2. So number 8 is the same thing, 180 degree rotation. Again, all of your coordinates just become the opposite sign. For these ones, it may be useful to know the rule, but you could always sketch it out to the side and rotate it and see what it ends up being if you forget. I'm going to skip 9 for a minute and do 10 while we're still doing 180. We have that rule in our head. Okay, so if we go back to number 9 and we're doing a 90 degree clockwise rotation, which is exactly what we were doing for number 3 on the front, this rule is that we are going to switch the coordinates and we're going to make the y coordinate become the opposite sign. Okay, so if I wanted to write this out real quick, I would switch the x and y coordinates, but the y coordinate becomes the opposite sign. So for s prime, if I think about changing y first, so -4 is now +4, and it goes first. And the x coordinate doesn't change, it just goes to be, it becomes the y coordinate. For w prime, 0, I can't change the sign of 0, so this is just going to switch. J prime, if I change the sign of my y coordinate and put it first, now it's 4. 3 becomes the new y coordinate and doesn't change its sign. Okay. Okay, so the last part here, we are figuring out what transformation happened. So if you look at number 11, clearly we can see that quadrilateral was rotated. We just have to figure out in which direction and by how much. So if you kind of take your paper and you mess around with like the turning of it, you should see that this was rotated 1 turn to the right. And so 1 turn, 90 degrees, and to the right means clockwise. And if you wanted to, you could check a point to make sure that that's accurate. So for example, if I check E, E was originally -2, 0. E prime is now 0, 2. And remember, for a 90 degree rotation, the y coordinate becomes the opposite and goes first, and the x coordinate becomes the y coordinate. So that's just a way to double check that you were correct. Okay, for 12, so clearly this was also rotated. If you look at how it was turned 2 times, and in this case it doesn't matter which way you say, because a turn of 2 times is 180 degrees. So we could just leave it as 180 degrees. We don't have to worry about specifying which direction, because it doesn't matter. Okay, for 13, if I look at my original triangle, which is the black triangle on my screen, and I have to figure out how was it turned to turn into the blue triangle, this was definitely a rotation. And hopefully if you turn your paper, you can see that it was turned twice to become the image. So this is another 180 degree rotation. Okay, and our last one, we are looking at triangle YHT. And if I look at triangle y prime, h prime, t prime, I can see again that it was turned 2 times, and it doesn't matter the direction. So that was another 180-degree rotation. Okay, so that's it for rotations today. The second lesson is going to be practicing this. So after you feel comfortable, you can rewind the video, you can pause it. When you feel comfortable, you can go ahead and watch day 2 of rotations.